Is on the project where we'll be discussing on a design of an instantaneous overcurrent relay and definite time overcurrent relay using MATLAB. So first, looking into the table of content, we'll be looking into background, introduction, literature review, project design, overcurrent protection relay and its types, MATLAB modeling on fault analysis of instantaneous overcurrent relay, MATLAB modeling of definite time overcurrent relay and its fault analysis, and the conclusions. So starting with the background, the electrical grid is like one of the most important and complex technologies in the electrical power systems, and like any other technology, it is also exposed to faults and interruptions, and many different problems might arise in the electrical power systems, and most of these are due to the surge in the system current, which can put the entire system at the risk of failure. And to protect the system against such failures, electrical relays are the most important essential components. And as a key strategy, overcurrent protection is used to protect the system from these kind of failures. So depending on the time and the current settings, there are like 4 different types of overcurrent protection approaches. Now moving on to the introduction, the 2 different types of overcurrent protection strategies were simulated in this paper using Simulink. The first one is an instantaneous overcurrent relay, like which operates and protects the system as soon as the current process and threshold limit, which is user defined. And the second one is an definite time overcurrent relay, which will be referring as DTOC in a further presentation. Actually, it responds to the fault current and then resumes the system back to its functioning to check whether if the malfunction is still available or it has been restored. And if the fault still persists, the relay again operates and isolates the system. So moving on to the literature review, a very simple and fundamental version of like overcurrent relay protection, overcurrent protection relay was designed by Maji and Ghosh. The functioning model of the overcurrent relay was designed using MATLAB, and it was simulated and tested for how the relay logic safeguards the distribution system. And also we have looked into one more paper which also examines by incorporating the overcurrent protection of an electrical grid using digital technologies like field programmable analog relays. Due to this, the overcurrent relay has the edge over the numeric relays, and then this paper looks into the benefits of the field programmable analog relays over the numerical relays. So in this paper, the author developed 2 types of overcurrent relay, where is very inverse type and inverse definite minimum time relays. And also apart from this, we have looked into several other papers. And now moving on to the project design. So in this project, we created 2 distinct overcurrent relays. One of them is a simple instantaneous overcurrent relay, and the second one is the definite time overcurrent relay, which is also referred as DTOC. So to be more specific, the design and implementation was carried out in MATLAB Simulink, and our understanding of the variations in both the relay logics will be evident in the modeling of these relays, and hope this will help us in choosing the relay which gives the best reliability, dependability, and the security and redundancy of the system. So now looking into the overcurrent protection. So this is one of the most simplest and widely used way of protecting any electrical system, to ensure that the breaker trips even if one of the phases is faulty during any kind of abnormal situation. These relays are used. So the relay design is very simple, and it can be used in various applications. So now looking into the types of overcurrent relays and its objectives. So basically an overcurrent relay uh, works to detect any abnormal conditions in the power system or the circuit, and it isolates that part of the system at a high speed, minimize the, the damage caused to the system, and it also differentiates between the faulty and the normal parts of the system. So looking into types of overcurrent relay, we have instantaneous overcurrent relay, definite time overcurrent relay, directional overcurrent relay, and in inverse time overcurrent relay we have three sub classifications, which is like moderately inverse, very inverse, and extremely inverse. So now this is our MATLAB dynamic modeling of the instantaneous overcurrent relay. The relay model which we constructed in the MATLAB sim link can be seen. To ensure that the breaker trips even if like one of the phases is faulty, the relay block uses like a relational operator, SR flip-flops, and AND logic. So basically the current values from each of the three phases are considered when this relay is operating, and with the aid of the RMS blocks the value of the current is determined. So since the relay decision is based on the RMS value of the current flowing through any of the phases at any given time, we'll be using these kind of blocks in this relay design. So further moving into the fault analysis, the first figure, the current wave during an LLG fault, shows that how the current value increases when a fault is introduced to the system. So as you can see here, the current value increased exponentially when the fault was increased, which is like from 0.25 0.25 seconds. So you can see this one, and the second graph shows how the instantaneous overcurrent relay sends a signal to the circuit breaker to stop the system after determining the abnormal current values during the fault. So this is very really evident, and we can say that the relay has operated and it has isolated the faulty system. So now moving on to the MATLAB modeling, and this is an definite time overcurrent relay. The relay model which we have constructed is seen, and basically both the relays operate very similarly. This relay also uses like a relational operator to compare the RMS value of three phases with a constant value. But what makes this relay design different is after the relational operator, the circuit is different. The trip signal is delayed by the definite time overcurrent relay using a counter. So basically when a fault occurs, the counter is engaged and it waits until the user time settings, like predefined user time settings, are met, and this is how the definite time overcurrent relay is different from instantaneous overcurrent relay. Fault analysis, these are the output plots of current wave during an LLG fault, and the second plot shows how the relay has operated during that fault. So in the first figure, we can see when the fault is added to the system, the current value increases exponentially, which is like from 0.09 seconds to 0.21 seconds. And the fault, this is the fault time, and the second figure shows how the relay operates as soon as the fault is detected, and the circuit's auto reclosure, it makes an effort to close the circuit and restore it to normal condition. However, if the situation still continues, the definite time overcurrent relay waits for a certain amount of time, which is user defined, and at which point it like once more transmits the signal to open the circuit if the fault still persists, and in that case it restores the system back. And now moving into the conclusion, so basically the main difference are fundamentally different from one another only in terms of logic and working principle. Only once the circuit is opened by an instantaneous overcurrent relay, and it stays open until the problem is fixed. Whereas in the definite time overcurrent relay, the circuit instantly is closed, and for a definite period of time which is hold, and if it closes back, if an auto reclosure is available. Other factors which differentiate these two relays are the like cost, and the significance and importance of the system, and types of failures which are to be against which the system has to be secured. And coming to other aspects, the instantaneous relay is like it's less expensive and it's simpler to install when compared to the definite time overcurrent relay, which is however a little more complex and expensive. Thank you.